dua, tiga. So, hello everyone. Today, my group consists of myself, Dennis, and Deva. Would like to explain you about sunscreen cream, especially in the perspective of and ceramics technology. So, okay, so the presentation consists of what is sunscreen itself, physical and chemical sunscreen, what is the sun UV radiation and the importance of using sunscreen cream, mechanism on the structure of physical sunscreen, and additional information regarding the ceramics in sunscreen.
Uh, okay, now I'm going to explain about what is sunscreen cream. So sunscreen, or known as sunblock or suntan lotion, I mean, is a lotion, spray, gel, foam, such as an expanded foam lotion or whipped lotion, stick, or other topical product that absorbs or reflects some of the sun's ultraviolet or UV radiation and thus helps protect against sunburn. So the increasing incidence of skin cancers and photodamaging effects caused by ultraviolet radiation has increased the use of sunscreening agents, which have shown beneficial effects in reducing the symptoms and reoccurrence of these problems. So the photo on the bottom right shows two photographs showing the effect of applying sunscreen in visible light on the right of the face. Or we can say that it's what the UV ray sees if they are seeing our face. So since there are two main keywords here, which are absorbs and reflects, I will explain to you about the meaning and the difference of absorb and reflects in sunscreen in the next slide. Okay, so there are two types of sunscreen, mineral or physical sunscreen and chemical sunscreen. They are both available in the market. So the first one I'm going to talk about is the chemical sunscreen. So it absorbs into the skin and then absorbs UV rays. And then converts the rays into heat and releases them from the body. So the active ingredients in chemical sunscreens include avobenzone, octinoxate, and oxybenzone. And then the next one is the physical sunscreen. So it sits on top of the skin and reflects the sun's rays. And then the mineral titanium dioxide and zinc oxide are the main active ingredients in the physical blocks. In the world of skincare, mineral sunscreen ingredients are referred to as organic, but they aren't. In the real world of science, mineral sunscreen ingredients are actually inorganic chemicals. So don't let these marketing terms influence your decision. Next. Next. Jill. Uh, okay, so this is the sun's UV radiation. So there are three kinds of UV radiation. The first one is the UVA radiation. So this radiation ranges between 320 to 400 nanometers. So UVA is most responsible radiation for immediate tanning or darkening of the skin due to excess production of melanin in the epidermis, premature photoaging, suppression of immunologic functions, and even necrosis of endothelial cells and damage of dermal blood vessels. And then there is the UVB radiation. So this radiation ranges between 280 to 320 nanometers. This radiation are known as burning rays as they are 1,000 times more capable of causing sunburn than UVA. So UVB rays acts mainly on the epidermal basal cell layer of the skin, but more genotoxic than UVA radiations. So UVB rays vary with time and season, are a major cause of sunburn. So sunburned skin is a leading risk factor for melanoma and non-melanoma skin cancer. And then the next one is the UVC radiation. So this radiation ranges between 200 to 280 nanometers. UVC radiations are filtered by stratospheric ozone layers, so less effective and hazardous.
Okay, so I will going to tell you about how important it is to wear a sunscreen cream every day. The image on the bottom right is the UV photography that shows the UV damage to your skin if you're not using sunscreen. Up to 80% of the sun rays can pass through the clouds. So if you assume it's okay to forget protection on an overcast day, think again. Sunscreen is important. Preventive healthcare habits you should be maintained all year, including in the winter months. So first, it can protect your skin from UV rays because the depletion of the ozone layer has increased our risk of sun damage from harmful UV rays. It lower your skin cancer risk. As my friend told you before, skin cancer is the most common form of cancer in the States, and UV light is considered as carcinogen by WHO. It prevents premature aging of the skin because sun damage from UV ray causes the photoaging of the skin, and it helps maintain an uneven skin tone, and it helps strengthen and make your skin barriers even more healthy. Okay, so this is the crystal structure of ZnO or titanium oxide. It is the main ingredients, the key ingredients in physical sunscreen. So my friends told you before, the main ingredients in physical sunscreen is zinc oxide or titanium dioxide. So crystalline titanium dioxide occurs naturally in three polymers: anatase, rutile, and brocade. Among all of the three, which rutile is the most stable. Research originating in Italy is encouraging sunscreen and cosmetic formulators to use the rutile form of titanium dioxide rather than anatase, as tests have suggested it is safer. Sunscreen typically, but not exclusively, contain rutile titanium dioxide powder, which is less photoactive than the anatase titanium dioxide. A powder with an average particle size of 230 nanometers scatters visible light, while its counterpart with an average size of 60 nanometers scatters UV light and reflects the visible light. Under UV, titanium dioxide exhibits photocatalytic activity, which is a consequence of the electronic structure of the titania and is to large extent more characteristic of anatase than rutile and brocade. In the presence of light with energy equal to higher than titanium dioxide band gap energy, an electron is promoted from the valence band to conduction band, leaving behind a positive hole. So the researchers have discovered that one of the most commonly used crystalline forms of titanium dioxide is rutile because it is also easily washes off and has little effect on the skin. Anatase, the other commonly used form, however, was difficult to wash and damage the outermost layer of skin, even in low UV light. So, nanoparticles of titanium dioxide are commonly in use in sunscreen, and it is partly because the particles are so small, like I said before, nanoscale of titanium dioxide doesn't reflect visible light and absorb UV light, allowing for a transparent barrier that shield the skin from harmful solar rays. Okay, So how is exactly physical sunscreen work? As I told you before, so first when you apply the sunscreen to your face, a sunscreen layer film begin to build up as you apply the sunscreen. So you should be applying sunscreen into finger much so it can coverage your face evenly, and as the sun UV rays hitting sun, the sunscreen layer will scatter the light or working as a mirror.
Okay, so I'm going to talk about the manufacturing of ZNO2, ZNO. As Sheila mentioned before, there are two ways in manufacturing of ZNO. The first one is the metallurgical processes, and the second one is the mechanochemical processes. Metallurgical processes for obtaining the zinc oxide based on roasting the zinc ore is the first one is direct and the second one indirect. The direct process involves the reductions of zinc ore by heating with a coal such as anthracite, followed by the oxidation of zinc vapor in the same reactor in a single production cycle. This process was developed by name of Samuel Walderhill and take place in a furnace which the first layer consists of a coal bed lit by heat remaining from previous charge. Above this bed is a second layer in the form of zinc or mixed with coal, and the blast air is fed from below. So to deliver the heat, both layers and carry carbon monoxide for zinc reduction. The resulting is zinc oxide that contains impurities in form of compound of other metals from the zinc ore, resulting the ZNO particles are mainly needle shape and sometimes spherical. Uh, to obtain a product with a permanent white color, the oxide of lead, iron, and cadmium, they are present converted to sulfates, increasing the permanence of the color to increase the content of water soluble substances and also increasing the acidity of the product. And the second one is the mechanochemical processes. Sorry. Before that, I'm going to talk about the indirect. The indirect process, metallic zinc is melted in a furnace and vaporized at 910 degrees Celsius. The immediate reaction of the zinc vapor with oxygen with the air produces ZNO. The particles of zinc oxide are transported via a cooling duct and are collected at a back filter station. The product consists of agglomerates with an average particle size ranging from zero point 0.1 to a few micrometers. The ZNO particles are mainly a spheroidal shape, and the process is carried out in a vertical furnaces with an original vertical charge, vertical refining column, vaporizer with an electric arc, and rotary combustion chamber. Okay, next one I'm going to talk about the mechanical processes. It involves the high energy dry milling, which will initiate a reaction through a ball powder impacts in a ball mill at low temperature. Mechanochemical processes is a cheap and a simple method to obtain nanoparticles on a large scale. It involves high energy dry milling, and then it will react the separates and nanoparticle being formed. A fundamental difficulty for this method is the uniform grinding of the powder and and reduction to grain to the required shape, which will decreases and increasing the time of energy milling. Unfortunately, longer milling time will lead into a greater quantity of impurities. For the advantage of this method is a low production of cost, a small particle size, and also a limited tendency for particles to agglomerate, as well the high homogeneity of the crystalline structure and morphology. Next, Jill. Okay, so as for manufacturing of titanium oxide, as you can see from the flow chart, the manufacture take place by either the sulfate process or the chloride processes. And the main raw of materials that include ilmenite, FAO, or titanium oxide. Naturally occurring the rutile or titanium slag. In essence, the process converts the impure of titanium oxide feedstock into an easy to purify intermediate, separates out the impurities, then it will convert back to pure of titanium oxide. Because of significant environmental and cost issues associated with the sulfate process, most of the manufacturing are based on the chloride process. The quantity of waste material is reduced compared to older sulfate process, but the chloride process is more difficult to operate, and the extreme corrosiveness of the high temperature chlorine, which range about 900 until 1000 degrees Celsius, and employed in the process contributes to the difficulty. Next, okay. Uh, and the mechanism of UVR attenuation, it was believed that in contrast to a chemical sunscreen, the physical metal oxides act as only scatters and reflectors to UVR. However, micronized form of metal oxides of the size below 370 Newton meter owe UVR attenuating ability to their absorbing power. Practically, no light being reflected whenever the light falls on a substance. A certain fraction of the incident light is either reflected, scattered, or absorbed. Absorption is a process in which light is lost. For example, it is converted into some other form of energy. The absorption of UVR by metal oxides is evident from the mobilization of electrons within their atomic structure. The energy required for mobilization is absorbed from UVR and will causing the metal oxide act as a photo semiconductors. The energy gap is the amount of energy required to promote the electron from the valence band into the conductive band. And this energy gap is calculated by using the quantum theory that will correspond to a UV wavelength of 385 Newton meter for ZNO and titanium oxide. Respectively, the absorbed energy is then will emitted as longer the wavelength radiations as the electrons return into the lower energy level. This whole event will occur within less than 10 seconds. Although metallic oxides are not inert per se, they can coated to make stable, non-toxic, and safe.
Okay, so that's all for our presentation today. Thank you very much.